Hello students, welcome back to the lecture series of software engineering course. Today I will cover one of the most important concept in software design, and that concept is called modularization. And as the name itself says, modularization is the process of dividing any software system into multiple independent modules where each module can work independently. And as you can see the definition of modularization, and it is measured by using two important criteria. One criteria is coupling, another criteria is cohesion. Generally, coupling is all about interdependency between the modules, and cohesion is about strengthening, functional strengthening of any module, how any module are functionally strengthable. So these two are actually the measuring criteria for any modularization. So I will start firstly with the coupling. So coupling basically measures the degree of interdependence between the modules. How one module is interdependent on another module. So if the coupling is high coupling, that means that the modules are strongly interrelated or interdependent to each other. But if the coupling is low coupling, then obviously modules are independent to each other. So the reason behind finding out the coupling criteria is basically it has been preferred that for any software design modularization, it is always desired to be low coupling, because low coupling generally means the modules are independent. So if any error or if any problem occurs in a module, then we don't need to change another module, or we don't need to find we don't need to test all the modules. Second important thing, if there is highly dependent among the modules, then if any occur arises, then it may affect all other modules. So the possibility of occurrence of error in the most interdependent modules are high compared to independent modules. That's why low coupling is always desirable for software design modularization process. So now I need to tell you the types of coupling. So I have mentioned over here six types of coupling. First, data coupling, stamp coupling, control coupling, external coupling, communicational coupling, and at last content coupling. And as you can see an arrow which is going upwards, which states that from the downward direction, this one is the best, and at the low, that is content, that is the worst. So if whenever I need to do couplings, then data coupling is the most desirable one, and content coupling is not at all desirable in the modularization process. So if I talk about the data coupling, so when the communication between the modules by passing the relevant data, that means कि data generally passed through the parameters. When this happened, कि only relevant data has been passed from one module to another, then such kind of coupling is called data coupling. Second one is stamp coupling. When the entire data structure has been passed, it occurs generally, stamp coupling occurs when entire data structure has been passed from one module to another, because generally entire data set is not required by the receiving module, only the part of the data structure may be required. So when stamp coupling will get occur when the entire data structure has been passed from one module to another. The third one is the control coupling. So control coupling is all about the communication between the modules by passing the control information. That means that one module controls the flow of another module is basically called the control coupling. Generally, for example, if a module has set a flag which has been used by another module, so such case control coupling will occur. Next is external coupling. when one module dependent on another module of some another software or hardware extend to the software system. Such kind of module is external. Such kind of coupling is external coupling. For example, if I do have a software system who has some module A and I do have another software system would have some module B. So if this module dependent on the another module of some another software or hardware extend to the software system, then such kind of coupling is called external coupling. Next, fifth one is communicational coupling. When two modules are using the common shared global data, then such kind of communicational coupling. And it is also not desirable to have communicational coupling, because when the error occurs, so it is very difficult to track which module has accessed or changed the data. Again, last one has, which is very low desirable, that is content coupling, when it occurs when the control of one module actually when a module's jo flow hai that has been controlled to the middle of another module. For example, if I talk about a module which is basically writing two instructions, and suddenly this is module A, and suddenly the control has been gone to the module B in the middle of the execution of the module, then such kind of coupling is called content coupling. So this is all about the types of coupling. So I hope you understand the types of coupling. Now come to the second measuring criteria of modularization, that is cohesion. Cohesion is all about to degree in which elements of a module are functionally related to each other. So if you see the types of cohesion, then there are 7 types and the arrow goes upwards. That means it is highly recommended to have a functional cohesion and very low recommendation of the coincidental cohesion. So if I talk about types of cohesion, so I'll start with the first one, functional cohesion. Functional cohesion generally when two modules are performing the same functional tasks in any module, then such kind of cohesion is called functional cohesion. Sequential cohesion, when the one operation in a module, the output of one operation in a module considered to be the input of another module. For example, I do have a module A and I do have instruction 1. So instruction 1's output would be the input of instruction 2. So whatever the output produced by instruction I1, that has been used by instruction of I2 as an input. So such kind of cohesion is called sequential cohesion. The third is communicational cohesion. When two operations are when two operations or two instructions are actually operating on the same input data or contributing to the same output data, such kind of cohesion is called communicational cohesion. Like if I do have two operations A or B, if they are using the same data, some input data C, or either this one, or they basically generates some data which is C, means when two instructions operate onto the same input data or contributed to the same output data, then such kind of cohesion is called communicational cohesion. Next is procedural cohesion. Generally, any operations can have different tasks, and for such operations having different tasks may have some particular order of execution, then such kind of cohesion are called procedural cohesion. For example, if some module has task A, B, C, D, E, right, and they are all different, but the occurrence of these tasks are following some order. For example, B will first, then A, then D, then C, then E. Then such kind of and such kind of particular order if they need to follow, then there is an occurrence of procedural cohesion. Next is temporal cohesion, when two operations are executed at a similar time. So such kind of time frame related cohesion are basically called the temporal cohesion. Next is the logical cohesion, when two operations are logically connected but not functionally. So such kind of cohesion are generally called the logical cohesion. And last is coincidental. As the name itself says, when two operations are not at all related to each other, but they are accidentally together. So such kind of cohesion are called coincidental cohesion. And that's why just because of they are together accidentally, that's why such kind of cohesion is low. So always for a standard or preferable software design modularization, it is always recommended to have high cohesion and low coupling. So by today's lecture, you do have an idea why we are calling about an ideal software design modularization as high coupling and low cohesion. So I'm expecting you guys understand today's lecture on modularization and its measuring criteria as coupling and cohesion, and you would better understand the types of coupling and types of cohesion. So I'm ending over here. If you do have any kind of query, you may write in the comment box. So thank you, students. Keep watching and listening.